Welcome to the presentation Typical Findings on Pipe Support Installations During On-Site Service. My name is Frank Bitthoff and I'm working for company Lisega here in Sieven, Germany. Introduction. Neither the use of the best pipe supports, the best piping engineers, the most detailed manufacturer's instruction manuals, or the highest level of material documentation allows to fully prevent mistakes during installation or maintenance of pipe supports. So this presentation shows the large variety of real-life examples of typical pipe supports findings often seen on site. It also explains why these mistakes can sometimes have severe consequences for the safe operation of the plant, and will also give recommendations how to prevent most of those mistakes. Pipe support types. Installations of the following type of pipe supports and safety elements will be shown. We will talk about constant hanger, variable hanger, snubbers, pipe clamps, and pipe shoes. Typical findings. The first picture shows a simple variable spring hanger without any nameplate or any other technical type of info. Same as the second picture here, it will make it utmost difficult to determine if the hanger is being put into the correct position or working properly. Other than saying it does work, cannot be done. Also on the third picture we see a little problem which often occurs, and that is, although theoretically there was technical data available on the nameplate, it was painted during any service potentially, so that no technical data can be seen from the distance either. So although there is a nameplate, also no technical information is available for a useful service. On the next picture, we will see a permanently attached blocking device to a variable spring hanger with the help of a threaded rod and some hex nuts. Basically, it's quite practical, but as we often see, there is a certain level of corrosion. So if the hex nuts are not turned into the correct position, or we face some level of corrosion, it will be difficult to reblock the items. As we can see here in the second picture, the hex nut was obviously somehow turning down and the support wanted to move up, which is not possible anymore in this case. The third picture here shows a wrong fixation of the blocking devices to a variable spring hanger by just some thin metal wire. Issue is that if you install these type of supports at a certain height, they can, by vibration, wind and corrosion, fall down after some while, and of course cause serious damages to anyone walking underneath. The fourth picture shows a blocking device which is put here without any safety measures. So that is of course also dangerous because it can fall off during some maintenance work and also cause damages and dislocation of the piping system. So there we come to the next issue which we can see from time to time, and this is the dislocation of piping due to no contact of pipe support with the pipe system itself. This can happen due to water hammers, earthquakes, or similar actions. It can also completely damage the support in some cases, as we can see in the second picture, and needs to be detected and of course the support be replaced. The problem in general, if you have plants in earthquake regions, let's say, is that the base support type pipe supports are not self-stabilizing. So we always recommend, when possible, to use a hanging type of support, which allows more dislocations than these type of bottom pipe support type F or type 29, as we call it in these cases. This one is another serious problem of a dislocated support. As we can see, it turns sidewise to the left side because it was not screwed correctly to the structure itself. So there must be taken care of that these things do not happen, because a few centimeters more, it can happen that yeah, the support will fall down, as well as the piping system, which of course does cause serious troubles. On this slide of typical findings, we will see three types of mistakes related to isolation. The first picture is a type 49 support, and as we can see, the screw connections are being put outside the insulation, and this must be avoided. So the whole type 49 support needs to be within the insulation, the whole pipe clamp, except of course the lower part of the foot of the base of the pipe support. The next picture shows a collision between a variable support, a sway brace, and the insulation. We have here a case where also some vibration is happening, and these type of mistakes must of course also be detected and avoided, so that no damage is put to piping or insulation material. The third picture is also an interesting one. We can see here that the type 29 pipe support is being put into the insulation, and the maximum working temperature of pipe supports in general is 80 degrees. So these pipe supports, neither constants nor variable hangers, must be put within the insulation. So they must always be put outside the insulation in order to have a proper temperature range for their working. This case is now quite an interesting one. We have a type 49 base clamp and a variable hanger trapeze underneath. They are soldered together, and the task was now to deblock the hangers and level everything. This caused some headache because it was simply not possible to get the blocking devices in a loose condition. So we were contacted in order to find out what is happening and why the support is not working properly. So the detected type of problem is not put here in order to encourage some seconds of own thoughts. So if you have looked at these supports maybe a little bit more closely, you will have detected that although the nameplate is now readable correctly, the threaded rods are fixed to the fixed point of the variable hanger on the top of the variable hanger, which cannot work. It's just a fixed connection now. So the solution here was to uncut the welded part, turn the trapeze 180 degree, and fix the threaded rods to the correct position of the spring hanger. In this case, this does mean that the nameplates are upside down, but that's totally correct, and the only way these items will work. So it must just be turned, and then it was easy, of course, to deblock and to level everything. So the next problem in relation to a trapeze installation is this one. Basically the same as we have seen before. It's a type 49 clamp base and a variable spring hanger trapeze. We can see here now that the nameplates, the Lisega nameplates, are put upside down. As we have just heard, this is totally correct. So the threaded rods are put to the correct part of the variable hanger trapeze. However, this installation is even more dangerous than the one we have seen before, and on the right side we can see another installation of the same type. So problem is here that the type 49 pipe shoes are dangerously installed in reverse. Dangerously because the max upward load of a type 49 pipe support is just 10% of the nominal catalog. So the force range is just then 10%, which means that we can have serious damages to the piping if you keep on installing them like this. They are just not designed to bear upward loads. So solution here is to disconnect the type 49 pipe clamps and put them onto the trapeze, and the trapeze of course then with longer threaded parts underneath the piping. So this is really quite a dangerous type of mistake, because utmost probably the type 49 pipe supports will not withstand the planned load. So the next typical finding was also quite a funny one, I must admit. We were contacted because the installation crew could not fix the Type 44 pipe clamp to the piping. They were just arguing that the U-bolts delivered were just too long. As we can see here in the picture, the upper part of the red upper part of the pipe clamp cannot connect to the piping, and the threaded part of the U-bolt surrounding the piping is obviously not long enough in order to fix the clamp to the pipe. However, the solution was not to deliver a different, smaller U-bolt. It was all delivered correctly, but a closer look to the installation and the use of the hex nuts showed that one hex nut was used above and one hex nut was used below the upper part of the pipe 44 pipe clamp, and the solution is quite easy. The lower hex nut is the counterlock hex nut for the upper part, which means that they would have just to install it the correct way, as we show in our little instruction on the catalog, and then it was detected that the U-bolt and the pipe clamp was delivered totally correct, and the mistake was easily erased. The next type of typical finding brings us to the so-called shock absorbers or snubbers. And here we have several problems detected in just, let's say, one complex installation situation. We see the snubber elements plus some extensions, and obviously the extensions go into the installation in the left part of the picture. So this is something which is not allowed, because all obvious connections, pin connections, are required to be outside of any insulation. In the background, the lower right part of the picture, we see a snubber at the very right, and then also some type of 35 element, a weld-on bracket, and the weld-on bracket is being continued with the threaded part of the non-dynamic support, and this does cause a variety of problems. It's a third angulation point in a dynamic position. Dynamic for pipe support means that they do work in extension and compression. And easy to imagine, if that thing works in compression, then the snubber will not be activated. It will just bend, and the third angulation point will not make the snubber work correctly. So far, obviously, nobody had any problem with it, obviously due to lack of problems in this position, but as it is a safety element, of course, the whole position needed to be redesigned. Another problem which we see sometimes is that the snubbers are being put into the insulation themselves as well. This is dangerous because the snubber working temperature is also at the maximum some 80 degrees. We recommend, of course, less, because we have hydraulic fluid inside and kind of rubber elements for the sealing system. And with higher temperatures, these elements will of course suffer and shortening the lifetime. And within the insulation, most probably we face higher temperatures. So the full snubber needs to be outside of any insulation. Here we continue with the snubber topic. These are so-called paint gun style snubbers, quite old ones, and in 99.9% of the cases which we have seen, they do not really work anymore. In the background we see the one which is missing the piston rod cover, which we can still see in the front, which will cause some dirt to be put onto the piston, and with moving back and forth this can work into the sealing system, and in almost all cases then we see that the oil reservoir, which is seen on the top part, is then not filled anymore with any oil, and in this case then without oil the snubber cannot work properly anymore, and in case of any emergency these safety elements will not work properly. So missing piston rod cover is here the problem, missing oil reservoir fluid is nearly always missing, and in most cases we also detect then leakages of the sealing system. The next type of typical finding, or I should rather say a little bit untypical finding, it's not too frequent, is that the deblocking of the constant hangers was not done correctly. We can see here on the left part of the picture that the center load pin of the constant hanger type 11 is coming out slowly, and on the other side of the constant hanger this pin is not seen anymore, and most probably it will fall down after a while. Issue is that the deblocking was not done correctly. So the initial situation is that you have the red blocking device in place. You would put out the metal rings and put out the red blocking device, and afterwards put back all the metal rings and just take out the blocking device. So the end situation would look like this, and this will prevent any pin of falling out. So the only thing you take out is just the red blocking device, and all the remaining rings which you see there during installation will remain at this position of the pin. So, and talking about correct positioning of the red blocking device, we see another frequent mistake, which is just the 90-degree turning of this blocking device and keeping it in place, as we can see here in the center of the picture. It does work to a certain extent, but it is definitely not recommendable because it will cause friction between the housing and the blocking device. Still, the blocking device can block between the big teeth and the device itself, so also movement can be hindered, and the scratching of housing and this blocking device will cause corrosion to happen. So after a certain time, most probably we will see that there is minimum high friction, if not a total blocking of the constant hanger. One typical mistake is the major deviation of the pipe support position of a constant hanger. The lower end shows with a red arrow the hot position. The real position is indicated by the load pin, and on the very top we would see the cold position. So the finding is a significant deviation from either cold or hot position, although the plant is of course either in hot or in cold condition. So possible causes can be wrong installation of the support, change in design after procurement of the supports, broken spring, rarely, but it can also happen, clash with a structure in other places of the piping system related to this support, a damaged or a missing other support, disconnected flange, or another variety of causes. So the issue is you can only find out the reason for this mistake when you analyze the whole system from fixed point to fixed point, and we never recommend just by one finding of one single pipe support to act or find any solution or change the system without checking the whole system. That's a very important issue always to keep in mind. Yeah, this type of problem is really a funny one if it was not so serious. So we really see sometimes a severe level of corrosion. Of course, these pictures are a bit exaggerated and extremes, but a detected type or generally detected type of problem is always a kind of level of corrosion, not always so serious as on the left or right picture here. The right picture gives another or shows another specialty. It's a lever arm constant hanger, and on the very right side of this picture we can still see some good looking yellow paint, and that is sometimes the problem of these type of hangers in severe environments. We detect the issue that the painting in 3 layers is still quite nice on the outside, but the problem is then on the inside of the housing, which is then the coil spring and the mechanical parts. So although sometimes these support look good from outside and fulfill maybe any specification due to severe environments, because these specs only go for the housing basically and for steel parts, the inside is always to be taken care of as well and carefully looked at. The next findings we show here are again of a lever arm type constant hanger. As it is a bit difficult to see, we just wanted to mention this. It's the inside of the housing where the coil spring is acting, and we see already here some scratches, which of course do cause some friction. And on the outside, we can also detect some deformation due to overloading or due to bad design, weak design. This type of friction frequently happens, and we see this from time to time. Another thing which can happen is that the load pin is scratching at the housing of this lever arm hanger, and that of course also does cause some additional friction of high level, and will not allow this item to work as a constant hanger, but will cause high load deviation and high stress for the piping system. So the mechanical parts again are always to be carefully checked, so that especially for constant hangers no additional friction is generated. During the presentation we already gave some recommendations how to solve some problems, but we wanted to summarize everything by giving some general recommendations. And the one important would be to make a visual inspection once a year during operation. Basically and generally, all pipe supports are maintenance free, but a supervision of their working condition is always recommendable. So the first task would be to identify the support type, tag number, theoretical hot and cold load position, the calibration and or operation load, or any other observations. Final recommendation. Final, but definitely most important. In case of any uncertainties, contact your pipe support expert. Any serious installation mistake is probably much more expensive than raising any question on time or getting an expert service. Just take a look at the left side and see that the piping system and the structure is only being connected by the pipe supports. So bad supports, bad piping system, a lot of stress can occur and a lot of problems can happen on site. In this regard, please also remember our saying that the piping can never be better than its supports. So I hope this presentation gave you a nice inside view of all the things or great variety of things which can happen on site. And it opens the eyes that a lot of care must be taken during the installation. So even though you use the best supports and you use the best engineering practice, take a look at the installations. Best thanks for your kind attention. In case of any question, please don't hesitate getting in contact with me. You see here again my email address. I would be looking forward to any question we could help you with. Again, best thanks for your kind attention.